So I can maybe start this panel with a question to our panelists. So yeah, maybe let's start with a more general question. So we have seen many LLMs and VLMs in the robot decision-making software stack. What do you think, which sensor modalities are necessary to achieve general purpose manipulation? Maybe, yeah, Ted, you already have the microphone, maybe you can.
Yeah.
If you want.
Sure. Yeah, sure. I guess I can give a very easy baseline answer to B, which is I think definitely vision is needed. I think it's already sufficient that we see that pixel to action large scale imitation methods can get surprising amounts of dexterity and generality, perhaps a lot more than any of us would have expected. Maybe based on all of the great limitations of such a limited modality that all of the great speakers showcased today, I would not have expected a year ago that you could do things like shoelace tying, for example, without things like force or tactile feedback. But clearly we can get a lot farther with a lot less than we would have expected. And so the question is, how much further can we go? Or if there are like kind of walls we're going to hit, do we have any, strong signs that the walls are already here or they'll be arriving soon?
Okay, so I think the short answer, I really believe that all the sensor modality is useful. Like I do feel like the more the better. But also I think there is some practical considerations that's why people are not using all the sensor modalities. I think one is once you add more sensors, you does make your system more fragile and easy to break. If one of the sensor breaks, the whole system kind of like is not function properly. And also, surprisingly, when you have more sensor modality, you are more likely to get out of distribution scenarios. Because if one of the modalities out of distribution, the whole input is out of distribution. So I think that from the first principle perspective, I feel like we should get all the information we can. But I think there also requires like maybe new machine learning method or like careful thought about system design to make them robust to deal with all the different type of sensor modalities. Yeah.
Yeah, and Christian, whenever you want to say something, just feel free to jump in.
So, for me, basically, what in CoRL I have heard about the tactile is not really tactile sensing, neither the gel side nor sorry, the microphone. When we are talking about the tactile information, basically is action conditions. And one of the reasons you were using the force torque sensors, because in our body, we have 5 million tactile sensors. We have cutaneous, we have ruthenian, and the others, and they are working in different frequency. And we have different spatial resolution for different tasks, right? So, and for me also is not only in hand manipulation, is also whole body grasp and manipulation. So when you are acting or basically executing any action, you will be able to get different properties. Like sliding, will give you another, for example, if you want to recognize the textural properties, friction, and so on. And when we want to develop anyway, manipulators, I don't believe that we have to just feed our networks with raw data, right? Because as I mentioned during my presentation, we have to consider at least 4 blocks. Multimodal sensation, interactive perception, and prediction, learning, decision-making, and so on. But what I can see here is basically one part, is learning. This is not really, we cannot really have a robotic system works in a dynamic environment using just the learning part, right? We have to consider everything in a loop, right? And the prediction is matters, for example, you were showing a cup. When you are grasping a cup, consider the cup is made of iron, or a stone, right? The same one, exactly the same of the cup made of plastic. So when the robot is grasping, the surprise happens, which is called predictive coding and active inference. It's completely different what basically we heard today, right? So we have to consider many things. It's not only the block, and we can say, oh, we have to just feed with a lot of data. So,
Yeah.
Oh yeah, I just want to quickly like respond to this. I think that yes, we probably don't need to always take in raw data, but I think it's extremely powerful and also like alleviating a lot of burden if we can actually directly use the raw data. And then I agree that if you have more intelligence, maybe you can train a policy that's able to reason about different materials of the object and then choose the action differently. However, that's quite hard. But what we show here is that with a very simple machine learning method, but just feed them different data, they're actually able to learn that strategy automatically. If you say that that's only learning, but maybe the learning also did a little bit of prediction and planning. Although I totally agree that for like a more long horizon tasks, we probably definitely need like more explicit planning and prediction. But for those like kind of reactive tasks or picking up a cup, we probably don't really need that kind of reasoning. Yeah.
Yeah, thanks. And maybe just for the other speakers to also have an opportunity to say that.
Yeah, so I don't have a lot to add. I think what I learned about the sensors in this CoRL is a couple of things. In the dexterity workshop in the morning, there was this hand with 4 fingers that would able to reorient objects without any visual feedback through the proprioception of those 4 fingers. So I feel like the more fingers we have, these more fingers allow even just knowing where the locations are to get a very good, understanding of how the object reacts to your forces, which I found very interesting. And yes, I think force is very important. Another thing that I found amazing is what Pulkit Agrawal said. He said manipulation is not about vision. The human is doing the next thing that he's about to do as opposed to what he's actually looking at right now. And I think this is quite correct. Yeah, so we definitely need this force feedback that Sean was talking about, and more than, I mean, there are too many vision-based methods, but I'm pretty sure next year is going to be way more force and tactile oriented and so on.
Thanks. Christian, do you want to add something?
Do you hear me? Yeah.
Yeah, maybe.
Do you hear me?
Yes.
All right, good. Well, not much, but I mean, if you really want to deploy these robots in the real world, right? Again, it's about, can we build these sensors in a robust way? And I think the tactile sensors are pretty fragile to this date. I think there needs to be more done here, and I think but I'm still amazed is kind of the combination of using internal measurements like force sensors in the joints, and how much you can predict using machine learning black box models, and you can inherently sense the touch. That there's some work I don't remember, but where you can touch the arm, and it actually can precisely predict where the contact point is and the contact force on the arm just from inherent sensing.
So you want to briefly get to 1 or 2 other questions, yeah, and maybe you can follow up. So another question, or something we also heard today, is about simulation, that this is also a very powerful source of data. And now I want to ask the panelists, what do you think, how can, or what are the best ways to combine this simulation data with actual like real world data to achieve in the wild manipulation capabilities?
For me, we cannot simulate tactile. It's impossible to simulate a tactile. Basically, it's a long time. It's 15 years I'm working on a tactile with Yasu Kuniyoshi. Basically, we were trying to find out even how many fingers do we need for the dexterous manipulation. It was like 15 years ago. And we don't need 3, we don't need 4, we need just 2 if we will have sensorized, 2 fingers. I think what is missing here, I can see people are not, how can I say, they don't know the state of the art, what have been done before many years ago. I think we have to little bit go back to see what has been done before. And the other thing is we cannot treat the tactile with the vision. So with the vision, you can collect a lot of data, millions of millions, even you have a camera, nothing can happen. If you have your finger, if you slide the finger on rough objects, after 5 times, start bleeding, right? So of course, you have to use different methodologies, right? And what comes to the humans, we are using uncertainty-based learning. right? So we are not feeding with millions of data the people, the system. Robot has to know how much data is enough, in order to learn something. So, and this is basically, it's called active perception and prediction based on uncertainty reductions. This is the thing basically is from my side.
Thanks.
You don't want to. Okay, go back to the original question about sim and real. I do feel like both of them are very powerful, but they do come with very different limitations. I think for manipulation, like all the context-rich tasks, I think it's actually really hard to simulate them properly. And especially if you think about the diversity of the object you need to interact with, I think that kind of feels very daunting to think about simulating all of this. But for local motion or learning the robot control is actually pretty doable in simulation. So that's why, like the Wumi Online thing, we have this combination of using real world data collection for manipulation and then learning the whole body controller in simulation. Yeah.
I think the reason I'm hesitant to say too strong opinions is that I think our team in the last few years has not invested too much in sim to real, especially for additional modalities beyond vision. I think my intuition here is just that I think with a lot of the scaling approaches we're looking at, we are really betting huge on the diversity and scale of internet data. And I think when you go from internet scale data to robot action data, that's already one distribution shift. You add other special modalities, depth, touch, 3D priors, that's another distribution shift. Then you add sim to real gap, you're building a house of cards. And so I think what we found is that when the one thing we want to keep is and measure and improve on is the generalization that we want to kind of take as little risk that may have the chance of hurting generalization as possible. It's definitely true that I think, we may be missing out on, very high performance in some specific settings, but I hope that our lessons for scaling and maintaining generalization can compose with the great works that are being done on pushing the limits of these modalities later on.
Thanks. The other two panelists, Katarina, Christian, do you want to add something?
Yeah, so one way, so some beautiful ways to combine sim and real is you can go to your real environment and, 3D perception works and you can reconstruct it and port things in simulation, and object detection works and tracking works. And also you can use essentially rewards simply from motion inference and appearance inference and directly instead of doing reward engineering. So that's one way. You can also, have demonstrations in the real world and use them with reinforcement learning and simulation to robustify your policies. I mean, for me, the most impressive robots right now, beyond, of course, Tesla car and Waymo, are, those locomotion robots and those leg guide robots. And these really show that they can generalize, and they use 1 billion interactions just to walk around, right? So manipulation hasn't showed anything impressive yet or something that works. In that respect, trying to combine sim and real sounds like a very good direction. And also simulators are also getting better and better and faster because there's also this trade-off, like, you can be more accurate on the contact representation, but then you are much slower. So people are pushing in this way. Now, at the limit, after 10 years, I don't think we may be using simulators. I think we're going to all be using neural simulators. We'll be figure out how to learn world models from data in sim and real, and we'll use our mental models to augment them any way we want, and scaling up mental data, but maybe not next year. I'm not sure.
Thanks, great point. Christian, do you want to add something briefly to that?
Yeah, I think one trick that people do nowadays, right, is to separate. So you basically learn a representation of the environment. So you have a visual model with some sort of representation, and then you plug it in and you train the motion with other methods, right? So you decouple vision and motion control, kind of. That's kind of powerful, and you can also kind of test the different modalities. But I think people didn't understand yet, right? What's the right connection? I mean, 20 years along, people distinguish, made the interface between motion and vision by a 6D breast pose, right? And that didn't work well. So there's some latent space that goes on and so on. But that's one way where you can make things work nowadays. But apparently, yeah, the world model idea is I think the path really going and these bigger models, right? But I think at the moment that this is kind of one of the approaches to deal with this variability in the perception data.
Thanks. So I think for the sake of time, we can maybe take one more question from the audience. So yeah, I think this was the first hand to go up. Yeah, please.
Yeah, so the question how to utilize probably only like several percent of them have those data, and there's still a lot of gap. So what's your take on that?
So just briefly for Christian, so the question was about how we can leverage internet scale video data, because there is the embodiment gap. Many of those videos don't have useful manipulation capabilities. Yeah, so yeah, Katerina.
Yes. So the first thing that was tried is let's use video data or image data to learn features, right? Like this R3M, I think is the paper called. I mean, that's one way, feature learning. Another thing that people do is they predict videos and they think that it's a good pre-training task for downstream policy. So this also has shown to work. Another thing is you learn video models and you use them as your simulators. They're going to be quite slow because you need to be generating pixels. One thing that I find particularly possible and easy to do in the next years is instead of just looking at videos as for feature learning, is you just really see it as essentially a simulation. You can see exactly where the hand is going and how the object is moving, and which part. Now we can estimate perfect camera motion with learning-based methods in the wild. And I really very much believe that we'll be able to do video to 3D to 4D and essentially use this for manipulation. Now, of course, this is for videos that show manipulation. If you have videos that, with cats jumping, I mean, they're not very related for robot manipulation, but there are a lot of videos of humans manipulating things that we're not using right now, like in Ego 4D, etc. I do believe that as perception is getting better and better, we will be able to use these priors.
Thanks.
Yeah, big plus one, I think, to using videos as a pre-training target and auxiliary task. I think it was Ilya Sutskever who once said, well, he believed that once superhuman video modeling is solved, robotics will be solved 6 months later. I don't know if that's quite as true. I think actions have a lot to add, but in general, whether video generation models are used as a pre-training task, as a world model for search, even at inference time, definitely good ideas. One question that, sorry to hijack, is maybe to the other panelists especially, is how do we think about combining internet scale data with non-video modalities for all of these very unique and important sensors, such as whether it's force or audio or tactile or whatever it is, where there isn't great coverage of internet scale data for these modalities? Like, how can we hope to generalize, right? Do we need to wait for maybe the next foundation models, which do have these modalities as a first-class citizen? Like next year, maybe there will be audio and video native foundation models for both input and output. Do we need to wait for one for a tactile foundation model, or how should we think about it?
Yeah, Sharon was shaking her head, so yeah, looking forward to that.
I think that's actually a very good question. And okay, so first of all, I feel video data, that's like it feels silly that not use it, right? It's there and it has like all this dynamic information. We should definitely use that for training policy. And then, but I feel maybe what we are really lacking is a very nice network architecture that maybe we already have it. Transformer probably can do that. That's able to kind of take in like different type of modalities very like organically. So I think right now, what we are thinking is that maybe we'll pre-train the visual encoder with video, and then we'll fine-tune it with action data. But it's possible that from the beginning, the transformer or whatever the foundation model already have all this input and outputs, but it just you can fit in different type of data to train different part of the network. So if you design it from the beginning, then problem is that later if we have tactile data, we can just train the same model, but with additional data inputs, and then it can just keep adding to the current model, and it can incrementally improve with more and more data instead of designing or training the network from scratch. So I hope that could potentially be one solution.
Thanks. So Mohsen and Christian, do you want to add anything?
Basically, as I said, this is a very computer vision approach, treating the robots. You know, for me, it's completely different. So for me, embodiment matters, right? Why there are many robots are failing, even they have a perfect vision, you know, because there is no embodiment involved during the training, during the learning. This is my hand. This is the reason I can hold this one, because I learned with this finger. Even if you change the properties of your skin, you know, it gets a little bit basically oily. You cannot grasp anything because you learned with this hand. So everything is not computer vision based approach, because we want to solve basically everything with the methodology algorithm we have in a computer vision, because it's easy. But if you want to treat other modalities, we have to go to another types of basically the methods. And I like transformers, but when it comes to the robotics, it doesn't work, because we have to do, how can we do the counterfactual learning? If the system making mistakes, how the system can learn from failures, right? This is the thing, even we have it in our human's brain, you know, when it comes from the walking, you can check your CPG, you know, then we learned walking from the failures, right? So how the system can learn, but transformers is great for basically language modeling. But when it comes to the physical system, like a robotic system, no, forget about it.
Yeah, then Christian, maybe one last take.
It would be super awesome, right? If you would just give a GoPro camera or even the Humi hand to our customers, human operators, and then they do their task, and then we get the data, and then robot let's train once and it's done. I think that would be really great if that works like that, and we don't have to send the robot and then teach it, you know, how to do things. Yeah.
Thanks. Yeah, and with this, I'd like to conclude the workshop, or at least this panel. And we have few more things to say, but very briefly. Yeah, so thanks again to our panelists. Yeah, and now just very briefly want to wrap up this workshop.
I thank everybody who attended the workshop, and especially the speakers who contributed to the workshop. Thank you so much for your fantastic talks. I think you tailored the talks to the workshop. Thank you so much. I think it was really interesting for everyone. We see this, I mean, 6 p.m. on a Saturday, and the room still, you know, we have a really good attendance. I think what we saw today was that we have a range of data, from robot-specific data to large-scale internet data, different sources of getting the data, simulation, teleoperation or demonstration, just the internet, real-world robotics data, getting the data through RL or self-play. I think there's still many open questions around just thinking about where the data comes from. And then we also saw that, you know, I think a general trend that additional sensor modalities improve performance if you combine them. And we also saw that language is a possible bridge, but I think just a general trend to look at different sensor modalities, which is very interesting. We also heard, including from the speakers from industry, that, you know, success rates are not yet there in many cases. And mitigating failures is something that we as researchers often don't look at. We just say, you know, in 20% of the cases it failed. That's not enough. And of course, I think in robotics, especially if you look at manufacturing, we are used to superhuman performance, right? I mean, what manufacturing robots do is something that no human can do in terms of accuracy and speed. And also that is something I think will be interesting to see where we get this from. Behavior cloning alone will not, you know, achieve this.
So I think there's still a lot of open questions, and I think we saw many interesting ideas today, and I hope you take something out of this workshop and continue interacting with our speakers and organizers. So thanks everyone, and thanks again, a big thank you really to all the speakers for their fantastic contributions to the workshop. Thank you so much.